Hi, Sevan. How are you? Hi, Twinkle. Twinkle, huh? Nice name. So we have one question. Why stars twinkle? Why planets does not twinkle? Okay, so come on, we'll go to the topic. Come on, get into the topic. So here you can see SI unit of current is SI unit of current is, so if I'm considering here, so I equal to Q by T, I equal to Q by T, I'm considering I equal to Q by T. So I is the current, I is the current, I is the current. So SI unit of current is ampere, SI unit of current is ampere, SI unit of charge is coulomb, SI unit of time is second. Once again, SI unit of current is ampere, SI unit of charge is coulomb, SI unit of time is second, SI unit of time is second. So I hope it is visible and audible to all. Okay, done. So now we can see here, we can see. So I'm taking I equal to Q by T, I equal to Q by T, I equal to Q by T. SI unit of current is SI unit of current is ampere, SI unit of charge is coulomb, SI unit of time is second. So 1 ampere equal to 1 coulomb per second, 1 ampere equal to 1 coulomb per second, 1 ampere equal to 1 coulomb per second. So 1 ampere of current is flowing through 1 ampere of current is defined as 1 ampere of current is defined as, okay. So 1 ampere of current is defined as 1 ampere of current is defined as, so 1 coulomb of charge flowing through unit cross section area per second, okay. So 1 ampere of current is defined as 1 coulomb of charge flowing through unit cross section area per second, that is 1 ampere. So SI unit of current is ampere, SI unit of charge is coulomb, SI unit of time is second. So ampere you should write small letters, you should not write capital letters. So for a symbol we can use, capital letter. For writing word you must write ampere. 1 ampere equal to 1 coulomb per 1 second. 1 ampere equal to 1 coulomb per second. So 1 ampere is defined as 1 coulomb of charge flowing through unit cross section area per second. 1 ampere is defined as 1 coulomb of charge flowing through unit cross section area per second is called is called is called 1 ampere. Okay. So quantization of charge. So inside of the conductor charges will move. Charges will not move one two like this, 1 2 like this. There are bunch of charges will move, so 1 or 2 it won't move. Okay, so like that we are considering, I hope it is very clear to you all. Charges will move like one or two, like there are many will move, many will move, bunch will move. Okay, so number, so integral multiple of charges, so charges will move in the form of integral multiple, so plus or minus ne, so why we are taking plus or minus? There are two types of charges, so positive charge and negative charge. Positive charge and negative charge. Positive charge will repel. Positive charge will repel. So positive, negative charge and negative charge will repel. Negative charge and negative charge, will repel. So positive charge and negative charge will attract. So two different charges will attract, two similar charges will repel. So you have to understand one thing: two dissimilar charges will attract, two similar charges will repel, I hope it is very clear to you all. Okay, so once again you can check here, two dissimilar charges will repel, two similar charges will attract, two dissimilar charges will attract. Two dissimilar charge means positive negative will attract. Two similar charges, similar charge means same charges, similar charges will repel. So here the point is similar charges, similar charges will repel, will repel, will repel, will repel. So dissimilar charges will attract, so dissimilar charges, dissimilar. Okay, so you are considering. So once again, similar charges will repel, dissimilar charges will attract each other. So that is about positive negative, or negative positive, like that. So number of electrons will move, a bunch of the electrons will move, q equal to plus or minus Ne, So here we need to remember one more thing is, okay, so on one electron how much charge is present, that is very very important. We will discuss now. On one electron how much charge is present, on one electron. So here you can see on one electron, 1.6 into 10 power minus 19 coulomb. So this much charge is present. In 1 coulomb, how many electrons are present? So we'll discuss about. Hi Ma, how are you? Fine, I'm good. So in 1 coulomb equal to 1 by 1.6 into, so 10 power 10 power 19 will not get. So let it be here. Okay, so we can write the same here. So 10 power minus 19, let it be. So if it goes up 1 by 1.6 into 10 power 19. So now 1 by 1.6 into 10 by 10 into 10 power 19. So then we'll get 10 by 16, that is 10 power 19. So then if you do it this one, you'll get 0.625. 0.625 will get 0.625. So I'll teach only physics. Sorry for that, only physics I'll teach. Okay, so let's see. So I'm taking 0.625 into 10 power 19. If you are taking 6.25 into 10 power 18. So that is in 1 coulomb. 6.25 into 10 power 18 electrons. So this is about in 1 coulomb. So in 1 coulomb, how many electrons are present? So 6.25 into 10 power 18 electrons. 6.25 into 10 power 18 electrons are present in 1 coulomb, right? So now you are considering. So now you can go for one more thing. So that's about related to electrons. So next one we'll see now we will see about electrical appliances. First one is cell. I'm taking. Second one is battery. Positive terminal, negative terminal, cell, battery, and coming to third one. Battery. So I'm considering here battery. And the third one, switch. Switch I am taking, switch. So you can contact this number 984981280 984981280. So anyone want required classes, so if you want your classes, okay, so you can contact this number, we'll discuss. So based on that one, we'll go through it. Okay. So now, so we are going to the next one. Next one. Next one. Next one. So battery. So next one is open switch. Open switch. Open switch. Open switch. And fourth one is closed switch. Closed switch. Okay. So this is a closed switch. Closed switch. I'm taking this a closed switch. Closed switch. And next one, fifth one, resistor. Resistor I am taking. This is a resistor. Resistor. Next one, sixth one, rheostat. Rheostat. This is a rheostat. Like this. Rheostat. Rheostat is a device. Rheostat. Rheostat is a device which is used to regulate the current. Rheostat is a device which is used to regulate the current without changing the voltage source. Without changing the voltage source, if it is regulating the current, that is called a rheostat. Next one, we are going to the seventh one, ammeter. Ammeter I am taking this ammeter. So positive terminal, negative terminal. Next one, voltmeter. Voltmeter. So positive terminal, negative terminal. Next one, okay. So wire joining. Wire joining. 10th one is wire crossing. Wire crossing. So ammeter, voltmeter. So wire joining, wire crossing. And 11th one, bulb. Bulb I am taking. So like this, the bulb. Bulb. Okay. So bulb. So this is about the electrical appliances. Electrical appliances. Once again, what are the electrical appliances are there? You can check one. Cell, cell, battery, open switch. You can see. So cell, battery, open switch, closed switch, resistor. So rheostat, ammeter, voltmeter, wire joining, wire crossing, bulb. Wire joining, wire crossing, bulb. So this is about electrical appliances. Electrical appliances, whatever we are discussing. Electrical appliances. Electrical appliances. Okay. So here we can take now open switch. If you connected the open switch in the circuit, that will become open circuit. If you connect closed circuit, so to the circuit it will be closed. And you can see resistor is a device. Resistor is a device which is used to oppose the electric current in the circuit. So resistor is a device which is used to oppose the electric current in the circuit. Resistance is the phenomena of opposing the electric current. Resistance is the phenomena of opposing the electric current. Resistor is a device which is used to oppose the electric current. Resistance is the phenomena of opposing the electric current in the circuit. So here SI unit of resistance is ohm. So here rheostat is a device which is used to regulate the current without changing the voltage source. So ammeter is a device which is used to measure the current, so connected series in the circuit. Voltmeter is a device which is used to Voltmeter is a device which is used to measure the potential difference. Voltmeter will be connected parallel to the circuit. Wire joining, wire crossing, and bulb. Wire joining and wire crossing and bulb. So these are the electrical appliances. Electrical appliances. Next one. So next one we will discuss about. Now we will discuss about. So we'll see. What a potential difference and electrical potential we'll discuss. Potential difference and electrical potential. Potential difference and electrical potential. So potential difference is nothing but potential difference. Potential difference. Electrical potential. So potential difference is nothing but, so we are doing some work. We are doing some work to bring unit positive charge from one point to another point. Okay, so work done to bring unit positive charge from one point to another point is called potential difference within the conductor. If it is happening within the conductor, if you are taking the within the conductor like this, so from point A to point B, point A to point B. So we are doing some work. We are doing some work. Positive terminal is there. Positive terminal is there. We are doing some work to bring unit positive terminal from point A to point B. Unit positive charge from point A to point B. So V equal to W by Q. V equal to W by Q. So we are doing some work to bring the unit positive charge. Unit positive charge from one point to another point within the conductor is called potential difference. SI unit of potential difference is volt. 1 volt equal to 1 volt. So SI unit of potential difference is volt. I am considering. SI unit of potential difference is volt. SI unit of potential difference is volt. Okay. So 1 volt equal to 1 volt equal to 1 volt. 1 volt equal to 1 joule by 1 coulomb. 1 volt equal to 1 joule by 1 coulomb. 1 volt equal to 1 joule by 1 coulomb. 1 volt is defined as 1 volt is defined as 1 volt is defined as 1 coulomb of charge. 1 volt is defined as 1 volt is defined as 1 coulomb of charge flowing through unit cross section. So 1 volt is defined as 1 volt is defined as 1 joule of work is done to bring 1 coulomb of charge from one point to another point. From one point to another point. So 1 volt is defined as 1 volt is defined as 1 coulomb of charge. 1 volt is defined as 1 joule of work is done to bring 1 coulomb of charge from one point to another point. 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 So here you can see we are doing. So what is 1 volt? 1 volt is defined as 1 volt is defined as 1 joule of work is done to bring 1 coulomb of charge from one point to another point within the conductor. Within the conductor, if it is happening, so 1 volt is defined as 1 joule of work is done to bring 1 coulomb of charge from one point to another point, from one point to another point, from one point to another point within the conductor. Within the conductor is called a volt. 1 volt equal to 1 joule by 1 coulomb. 1 volt equal to 1 joule by 1 coulomb. And coming to the electrical potential is nothing but, so the work done to bring electrical potential, electrical potential, electrical potential, electrical potential. Electrical potential is nothing but, so work done to bring unit positive charge from infinity to the required field. So work done to bring unit positive charge from infinity to the required field is work done to bring unit positive charge from infinity to the required field is, from infinity to the required field is electrical potential. Electrical potential is nothing but, so here taking, so this is the, what is this one? So infinity I am taking this infinity. Okay, so infinity I am considering here. Infinity. Okay, so infinity I am taking. This is about infinity. Infinity point, positive charge. Positive charge. This is the required field, required field, required field, required field, required field. Okay, so we are doing some work. We are doing some work to bring So you need positive charge from infinity to the required field, from infinity to the required field, from infinity to the required field, from infinity to the required field is called electrical potential. Electrical potential. So same 1 volt equal to 1 joule by 1 joule by 1 coulomb. So same thing we can take V equal to W by Q. 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 So electrical potential, electrical potential, electrical potential. Electrical potential. Electrical potential, right? So work done to bring unit positive charge from one point to another point within the conductor. Within the conductor, the work done to bring unit positive charge from one point to another point is called potential difference. Work done to bring unit positive charge from one point to another point within the conductor is called potential difference. Work done to bring unit positive charge from infinity to the required field, from infinity to the required field, from infinity to the required field, from infinity to the required field is called electrical potential. Is called electrical potential. So I hope it is clear between potential difference and electrical potential. So we will go to the Ohm's law. Problems will do. Problems also there. Problems we have to do it. So it will take time, but still we will do the problems. So now Ohm's law. So we'll discuss about Ohm's law. Ohm's law. Ohm's law is nothing but, so here I am taking the resistor. So current is passing. So the potential difference across the potential difference across a metallic conductor. So V is directly proportional to I. The potential difference across a metallic conductor at a given temperature. So at a given temperature, at potential difference. So the potential difference across the potential difference across the ends of the given metallic wire, the potential difference across the ends of the given metallic wire is directly proportional to current flowing through it. Sorry, current flowing through it. So current flowing through it. So V is directly proportional to I, V equal to IR. So the potential difference across the ends of the metallic conductor. So potential difference across the ends of the metallic conductor. Potential difference across the ends of the metallic conductor. Across ends of the given metallic conductor. The potential difference across the ends of the given metallic conductor. So V is directly proportional to I, V equal to IR. V is directly proportional to I, V equal to IR. V is directly proportional to V equal to IR. V is directly proportional to V equal to IR. V is directly proportional to V equal to IR. the potential difference across the ends of the given metallic wire, given metallic conductor, the potential difference across the ends of the given metallic conductor is directly proportional to current flowing through it. Is directly proportional to current flowing through it. V is directly proportional to I, V equal to IR. V equal to IR. So Ohm's law gives the definition of resistance. 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 So if the current is passing, next one, materials required. What are the materials required? Materials required. So if we are talking about materials required, so if you are considering first one you are considering, first one you have to take four cells. Four cell you have to take. Four cells, 1.5 volts each. Second one, you are taking nichrome wire. Nichrome wire is an alloy of nickel, chromium, manganese, and iron metals. Nichrome wire is an alloy of nichrome wire is an alloy of nickel, chromium, manganese, and iron metals. So here we are considering what are the materials required for the activity of Ohm's law. So once again, I will discuss about Ohm's law definition. At a constant temperature, the potential difference across the ends of the given metallic conductor is directly proportional to current flowing through it. V is directly proportional to I, V equal to IR. V is directly proportional to I, V equal to IR. So for doing activity, for doing Ohm's law, we need materials. What are the materials required? Four cells. So 1.5 volts each. So like that, I'm taking four cells. Here. I'm taking 1.5. Here also 1.5 volts each. Like that, 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. So four cells. So I'm taking four cells. So four cells I'm considering. So 1.5 volts each. Four cells, 1.5 volts each. 1.5 volts each. Nichrome wire is an alloy of nickel, chromium, manganese, and iron metals. Nichrome wire is an alloy of nickel, chromium, manganese, and iron metals. Nichrome wire is an alloy of nickel, chromium, manganese, and iron metals. Nichrome wire is an alloy of nickel, chromium, manganese, and iron metals. It is an alloy of nickel, chromium, manganese, and iron metals. Nichrome wire is an alloy of nickel, chromium, manganese, and iron metals. Nichrome wire is an alloy of nickel, chromium, manganese, and iron metals. Okay, so 0.5 I am taking. Coming to the third one, I'm considering. Third one, so for third one, I'm taking ammeter. So fourth one is voltmeter. I'm taking voltmeter. Ammeter, voltmeter. So fifth one you are considering. Next key I'm taking. This is a key. See, switch, open switch. So actually, if your dot is the switch. Sixth one we'll talk about. Sixth one is about connecting wires. Okay, so four cells, nichrome wire, ammeter, voltmeter, switch, connecting. Next, connecting wires only. Connecting wires. Okay, come on. So six materials required. These are the 6 materials required. I hope it is very clear to you all. Okay, so next one. So 4 cells 1.5 volts each. Nichrome wire is a nickel chromium. Nichrome wire is an alloy of nickel, chromium, manganese and iron metals. Nichrome wire is an alloy of nickel, chromium, manganese and iron metals. Manganese and iron metals. Okay, ammeter, voltmeter, switch, connecting wire. So these are the materials required. These are the materials required. Next one, procedure. Procedure. What is a procedure? Procedure is procedure. Procedure is take the connect one cell and note down the reading of connect one cell, connect one cell, connect one cell, connect one cell, connect one cell I am connecting, one cell I am connecting, connect one cell and note down the reading of ammeter and voltmeter. And the second one, connect two cells, connect two cells, connect two cells, and again note down the reading of ammeter and voltmeter once again. So what is the procedure? Procedure is connect one cell first, one cell in the circuit and note down the reading of ammeter and voltmeter. Next, connect to two cells and note down the reading of ammeter and voltmeter. So you can mention in the tabular form given below. So mention in the tabular form given below. So you have to mention in the tabular form. You have to mention in the tabular form. So serial number, number of cells, ammeter reading, voltmeter reading, V by I form, V by Y form. So you are considering 4 cells. I am taking 1, 2 and 3, 4. Okay. So I'm taking serial number, number of cells, ammeter reading, voltmeter reading, V by I form. So here I'm considering R equal to V by I, R equal to V by I, R equal to V by I. So that's why we are taking V by I value, that is the resistance, V by I value is the resistance. Okay. So now you are considering, so next 3 cells, 3 cells you have to take, 3 cells and 4 cells. Repeat the process for 3 and 4, and note down the reading of ammeter and voltmeter. Serial number 1, 2, 3, 4, 1, 2, 3, 4. Okay, so here I am considering once again Ohm's law is nothing but so the potential difference across the ends of the given metallic conductor, the potential difference is nothing but the Ohm's law is nothing but the potential difference across the ends of the given metallic conductor. So potential difference is nothing but the potential, Ohm's law is nothing but the potential difference across the ends of the given metallic conductor is directly proportional to current flowing through it. Ohm's law is simple, very easy. That is the potential difference across the ends of the given metallic conductor is directly proportional to current flowing through it. V is directly proportional to I, V equal to IR. V is directly proportional to I, V equal to IR. V is directly proportional to I, V equal to IR. Okay. So materials required. So this is a circuit diagram, very important. This one they will give for 2 marks. Circuit diagram. And materials required. 4 cells of 1.5 volts each. Nichrome wire is an alloy of nickel, chromium, manganese and iron metals. So 0.5 meter length. Ammeter, voltmeter, switch and connecting wires. So procedure. What is the procedure to do this one? First, connect one cell and note down the reading of ammeter and voltmeter. Connect one cell and note down the reading of ammeter and voltmeter. And connect to two cells and note down the reading of ammeter and voltmeter. And so mention those values in the tabular form. This is the tabular form. And connect, so repeat the process for 3 and 4. Repeat the process for 3 and 4. If you after finding ammeter and voltmeter values, so you can mention in the tabular form. If you draw the graph for VI, if you draw the graph for VI, so we can see, so it will be straight line. So moving from the linear, so I'm taking this one. So VI graph gives the linear position. So V I am taking on y axis, I am taking x axis. So graph is linear. Okay, so this means current is potential difference is directly proportional to current flowing through it. Potential difference is directly proportional to current flowing through it. Potential difference is directly proportional to current flowing through it. Potential difference is directly proportional to current flowing through it. So V is directly proportional to V equal to IR. So this will follow Ohm's ohmic conductor. Ohmic conductors means The substances which obey Ohm's law, the substances which obey Ohm's law, those are called ohmic conductors. Coming to the non-ohmic conductors, non-ohmic conductor, non-ohmic conductors, non-ohmic conductors are the substances which does not obey Ohm's law. The substances which does not Ohm's law, those are called non-ohmic conductor. The substances which does not obey Ohm's law, those are called non-ohmic conductors. The non-ohmic conductor graph is curve, not linear. Okay. So ohmic conductor, the substance which obey Ohm's law, those are called ohmic conductors. So non-ohmic conductor, the substance which does not obey Ohm's law, those are called non-ohmic conductors. Non-ohmic conductors. So this is about Ohm's law. This is about Ohm's law. Once again, you can observe here. So Ohm's law is nothing but the potential difference across the ends of the given metallic conductor is directly proportional to current flowing through it. V is directly proportional to I. V equal to IR. So now Ohm's law gives the definition of resistance. 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 Materials required. 4 cells I am taking 1.5 volts each, 1.5 volts each, 1.5 volts each, 1.5 volts each. So 1.5 volts I am taking. A nichrome wire is alloy of nickel, chromium, manganese and iron metal, that is 0.5 meter. Ammeter, voltmeter and switch connecting wires. So now these are the materials required. These are the materials required. Now procedure. So what is the procedure to do the activity? First connect one cell, connect one cell, connect one cell, connect one cell and note down the reading of ammeter and voltmeter. Connect one cell and note down the reading of ammeter and voltmeter. Connect one cell and note down the reading of ammeter and voltmeter. Next connect to two cells, and note down the reading of ammeter and voltmeter. So mention in the tabular form given below. Mention in the tabular form given below. So you have to take serial number, number of cells, current, ammeter reading current, voltmeter reading potential difference, V by I form. That is nothing but R value. Okay. So R value I am taking, right? So this is the procedure. If you draw the graph for VA, if you draw the graph for potential difference and current, so potential difference on y-axis, current on x-axis, the graph is linear. So coming to the non-ohmic conductors, the graph is not linear, it will be straight line. So the graph is not linear, it will be curve. Okay, so it will be curve. So that is about Ohm's law. I hope it is very clear to you all. You can check once. This is a complete about Ohm's law. Okay. So next one, factor depends on resistance. Factors depends on resistance. Okay. So what are the factor depends on resistance? We'll discuss now. Okay, so now resistors are connected in series combination, resistors are connected in parallel combination. We'll discuss. So now till now we discussed about Ohm's law. Now we'll discuss about resistors are connected in series combination, resistors are connected in parallel combination. Resistors are connected in series combination. So I'm taking resistors are connected in series combination. So I'm taking one resistor like this and one more. So that I'm connecting to the battery. So here I am considering. So here you can observe positive terminal, negative terminal, current is passing like this. So here across this one, potential difference V1, R1, R2, R3, potential difference V1 and V2, V1, V2, V1 and V2 and V3, V3 I am taking here. Okay, so current is passing like this. Here also it is passing. So here also it is passing. Here also it is passing. Current is passing I. Okay, throughout the path the current is same. Throughout the path the current is same. Though throughout the path the current is same. So that's why if the current is same, then how can we take like this? So from Ohm's law V equal to IR. From Ohm's law V equal to IR. From Ohm's law V equal to IR. From that, so here current is same. IS equal to I1 equal to I2 equal to I3 equal to I, because current is passing entire circuit. Current is passing in the entire circuit is same. Current is passing in the entire circuit is same. Current is passing in the entire circuit is same. Coming to the potential difference. Coming to the potential difference. So potential difference Vs equal to V1 plus V2 plus V3. Potential difference Vs equal to V1 plus V2 plus V3. 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 Okay, I'm taking like this. So IRS equal to IR1 plus IR2 plus IR3. So here I we can take common. I you can take common. So now you are taking I common. RS equal to R1 plus R2. So here you are taking I get cancelled. I get cancelled. RS equal to R1 plus R2 plus R3. So resistors are connected in series combination formulas. Resistors are connected in series combination formulas. Resistors are connected in series combination. Resistors are connected in series combination. Formula you are taking. Formula is so next I Vs equal to V1 plus V2 plus V3. Vs. Okay, Jaydeep. So we'll see that one. So Vs equal to V1 plus V2 plus V3. IRS equal to IR1 plus IR2 plus IR3. IRS equal to IB are taking common R1 plus R2 plus R3. II get cancel. II get cancel. RS equal to R1 plus R2 plus R3. RS equal to R1 plus R2 plus R3. RS equal to R1 plus R2 plus R3. If n number of resistors are connected in series combination, RS equal to NR. And if n number of resistors are connected in series combination, if n number of resistors are connected in series combination, then RS equal to NR. If n number of, so next resistors are connected in parallel combination. Resistors are connected in parallel combination, we'll discuss. Resistors are connected in parallel combination. So how it will be, we'll see. Okay, so resistors are connected in parallel combination. Coming to parallel combination. So now we'll see the parallel combination. Resistors are connected in parallel combination. So now how it will be? So here I am considering resistors are connected in parallel combination. Parallel combination. Resistors are connected in parallel combination. So I'm considering here. So here if you are taking, if you are considering here, so 1, 2, 3. So resistors are coming like this. So ammeter, so R1, R2, R3. So I'm taking potential difference. So here I am taking when the current is passing. If the current is passing from the battery, then we can see here, okay, so current is dividing into three parts like this. So I1, I2, I3. I1, I2, I3. So current is dividing into three parts. Now from Ohm's law V equal to IR, 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 from Ohm's law V equal to IR. So like that you are considering. So we know potential difference is same, only current is dividing. So I equal to V by R, I equal to V by R, I equal to V by R, I equal to V by R. So potential difference, if you are taking IP equal to I1 plus I2 plus I3, I1 equal to IP equal to I1 plus I2 plus I3, IP equal to I1 plus I2 plus I3. So V by RP equal to V by R1 plus V by R2 plus V by R3. V by R3 I am taking. V by R3, right? V by R3 I am considering. V by R3 I am considering. Okay. So now we are considering here V by R3. V by R3. So V we are taking common. 1 by RP equal to. So V are considering. V are I am taking common again. Here also V I am considering common. V I am taking common here, okay. So V, if you take common, 1 by R1 plus 1 by R2 plus 1 by R3, okay. So V get cancelled. The final formula is 1 by RP equal to 1 by R1 plus 1 by R2 plus 1 by R3. So 1 by RP equal to 1 by R1 plus 1 by R2 plus 1 by R3. So now we can take, if n number of resistors are connected in parallel combination, 1 by Rp equal to n by R, Rp equal to R by n, I hope it is very clear now. You can check. So if the resistors are connected in parallel combination, okay. So whatever the current is passing from the battery, so that is dividing into three parts. So across R1 V1, across R2 V2, across R1 I1, across R2 I2, across R3 I3, across R1 I1, across R2 I2, across R3 I3. Okay, so current is passing. The overall current in parallel combination equal to IP equal to I1 plus I2 plus I3. IP equal to I1 plus I2 plus I3. I1 equal to, so I1 equal to IP equal to I1 plus I2 plus I3. So overall current in parallel combination. So IP equal to I1 plus I2 plus I3. So IP equal to V by RP. IP equal to V by RP. I1 equal to V by R1. I2 equal to V by R2. I3 equal to V by R3. So like this we can take. Right? So like this we can consider. So IP equal to I1 plus I2 plus I3. So V by RP equal to V by R1 plus V by R2 plus V by R3. So 1 by RP equal to 1 by R1 plus 1 by R2 plus 1 by R3. So 1 by Rp equal to 1 by R1 plus 1 by R2 plus 1 by R3. So if n number of resistors are connected in parallel combination, 1 by Rp equal to n by R, that is nothing but Rp equal to R by n. Rp equal to R by n. So that is about resistors are connected in parallel combination. So one more point is there, that is resistors are depends factor on which resistance depends. Okay, so we'll see resistance factors. So resistance depends on length of the conductor. Resistance depends on length of the conductor. R is directly proportional to L. R is inversely proportional to area. R is directly proportional to L by A. R equal to rho into L by A. So here R is a resistance. Rho is the resistivity. R is a resistance. Rho is the resistivity. R is a resistance. Rho is the resistivity. R is a R is the resistance, rho is the resistivity. R is the resistance, rho is the resistivity. R is the resistance, rho is the resistivity I am taking. So resistance depends on length of the conductor. Resistance depends on length of the conductor. Resistance depends on area of the conductor, area of the cross section. R equal to L by A, directly proportional to L by A. R equal to rho into L by A. R is the resistance, rho is the resistivity. R is the resistance, rho is the resistivity. So from here, rho equal to RA by L. RA by L. Rho equal to RA by L. SI unit of resistance is ohm. SI unit of area is meter square. So meter might get cancelled. Then ohm meter. So rho is the ohm meter. Okay. SI unit of resistivity is ohm meter. 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 SI unit of resistivity is ohm meter, right? So SI unit of resistance is ohm. 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 SI unit of resistivity is ohm meter. SI unit of resistivity is ohm meter. SI unit of resistivity is ohm meter. Okay. So now we'll discuss about difference between resistance and resistivity. Okay, hi everyone, welcome to the student brand. Again, explanation will start. Explanation will start. Explanation will start. Okay, we'll start the explanation. So now, resistance and resistivity. Come on. Resistance and resistivity. Yes or no? Resistance and resistivity will discuss. Resistance and resistivity. Now you see, observe here, okay. So when you are taking here, resistance is the phenomena of opposing the electric current. Resistance is the phenomena of opposing the electric current. Resistance is the phenomena of opposing the electric current. Yes or no? Resistance is the phenomena of opposing the electric current. So R equal to rho into L by L. So SI unit of resistance is ohm. This is the SI unit. So here we have to write SI unit. This is the SI unit. I am writing here SI unit, and this one also SI unit, SI unit, SI unit I am taking here, SI unit, and the symbol if you are taking resistance symbol, resistivity ohm meter, and resistance depends on length of the conductor, resistance depends on length of the conductor, resistance depends on area of the conductor, area of the cross section, and resistivity does not depend on length and area. Resistivity does not depend on length and area. So it is a property of the matter. It's a property of the matter. Resistivity is a property of the matter. And resistance depends on temperature. Resistivity also depends on temperature. And coming to the resistance depends on metal of the conductor. Resistivity also depends on metal of the conductor. Metal of the conductor, what we are using, metal of the conductor. I hope it is very clear to all. I hope it is very clear to all. So this is about resistance and resistivity. Resistance and resistivity differences. Okay, so difference between resistance and resistivity. Now we will go into the factors. So I hope it is already clear. Now we will discuss about heating effect of electric current. Heating effect of electric current will discuss. Now we will discuss about heating effect of electric current. Heating effect of electric current. Heating effect of electric current is nothing but, so normally if you are saying here, heating effect of electric current, heating effect of electric current, heating effect of electric current. So the potential difference is directly, the potential difference V equal to, the potential difference V equal to W by Q. The potential difference V equal to W by Q. The potential difference V equal to W by Q. So work done to bring unit positive charge from one point to another point. Work done to bring unit positive charge from one point to another point. Work done to bring unit positive charge from one point to another point. Work done to bring unit positive charge from one point to another point. Work done to bring unit positive charge from one point to another point. Work done to bring unit positive charge from one point to another point. Work done to bring unit positive charge from one point to another point within the conductor is called potential difference. V equal to W by Q. V equal to W by Q, V equal to W by Q, V equal to W by Q, V equal to W by Q. V is the SI unit of V is the potential difference, W is the work, Q is the charge. Now W equal to V into Q. So we are doing electrical work. That electrical power is nothing but rate of doing work. Electrical power is nothing but what is electrical power? Electrical power is nothing but rate of doing work. Rate of doing work. Electrical power is nothing but rate of doing work. Electrical power is nothing but rate of doing work. Electrical power is nothing but rate of doing work. P equal to W by T. So VQ by T, that is nothing but V into Q by T. That is nothing but V into Q by T. P equal to V into Q by T is I. Q by T is I. Q by T is I. The rate of log charge. The rate of log charge. 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 Rate of log charge is nothing but electric current. Rate of log charge is nothing but electric current. Rate of log charge is nothing but electric current. Rate of log charge is called 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 electric current. I equal to Q by T. 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 So now you are considering here. So P equal to VI. Energy is given to the conductor is equal to P into T. So whatever the energy is given to the conductor, that will become in the form of heat. In the form of heat. So whatever the energy is given to the conductor, that will become in the form of heat. That will become in the form of heat. Then so H equal to, so V I am considering into T. We know V equal to IR. V equal to IR. V equal to IR. H equal to Vi into, okay, so V value in the place of V, in the place of V can be substitute, in the place of V can be substitute IR, in the place of V can be substitute IR, in the place of V can be substitute IR, yes or no, we can substitute IR into I into T, IR into I into T, then we'll get I square RT, I square RT, I square RT. H equal to I square RT, H equal to I square RT, H equal to I square RT. Heat produced in the conductor is directly proportional to square of current, is directly proportional to resistance, is directly proportional to temperature, directly proportional to time. H is directly proportional to square of current, H is directly proportional to resistance, H is directly proportional to time. So this is about heating effect of electric current. Heating effect of electric current. Example, so this will be, so here, what are the applications of heating effect of electric current? Electrical cooker, electrical oven, electrical cooker, electrical oven, and we can say room heaters, electrical oven, electrical oven. These are the applications of heating effect of electric current. The source of energy continuously gets dissipated. The source of energy continuously gets dissipated entirely in the form of heat. The source of energy continuously gets dissipated. The source of energy continuously gets dissipated entirely in the form of heat is called heating effect of electric current. Is called heating effect of electric current. Is called heating effect of electric current. Heating effect of electric current. Heating effect of electric current. I hope it is very clear to all. So heating effect of electric current. Okay. So now we can go for a short circuit. The direct contact of live wire and neutral wire takes place. The direct contact of live wire and neutral wire takes place. Then heavy amount of current will be drawn from the main. Then so it leads to the fire. It occurs fire in the building. It occurs fire in the building. It occurs fire in the building. And overloading. High voltage appliances on at a time in the circuit. High voltage appliances on at a time in the circuit. High voltage appliances on at a time in the circuit. Then heavy amount of current will be drawn from the mains. Then heavy amount of current will be drawn from the mains. High voltage appliance. If you are taking here high voltage appliances, like a washing machine, geyser, like a grinder. So like this type of high voltage appliances on at a time, at a time, then it leads, it draws heavy amount of current from the circuit. Heavy amount of current will draw from the circuit. Then it leads to the short circuit. So the wire will melt and break. Then it leads to the short circuit. I hope it is very clear to you all. That is about overloading at short circuit. Coming to the live wire, neutral wire. I'm taking live wire. Live wire is a positive terminal, red in color. So second one is neutral wire. Neutral wire is black in color. So black color. And third one, earth wire. Earth wire is in green color. Green color insulation. Okay, so the potential of live wire is 220. The potential of live wire is 220 volts. The potential of neutral wire is 0. The potential of earth wire is 0. The potential between live wire and neutral wire is 220. The potential difference between live wire and neutral wire is 220. The potential difference between live wire and earth wire is 220. Earth wire is 220. Okay, so third one, the potential difference between neutral wire and earth wire is 0. Neutral wire and earth wire is 0, because so here I am considering the potential difference. So one more question is very, very important in the exam point of view. This question will come. The potential difference between live wire and neutral wire is 220. The potential difference between live wire and earth wire is 220. The potential between neutral wire and earth wire is 0. Potential difference between neutral wire and earth wire is 0. Okay, so this is about electric current. So topic is completed. So we'll see any problems are left. So we'll discuss the problems we didn't discuss, only we discussed about the concept. Again 6 o'clock live class is there. So I'll start one more chapter, light reflection and diffraction chapter, and we can see human and colorful world, magnetic electric current. So remaining chapters also I'll discuss. You can join at 6 p.m. again. So thank you so much for joining. So see you soon. Namaste.